All right, so this video is about how to simplify rational expressions. And just to be clear, again, I like to define the key terms and actually go over what these words mean. Simplify, way of saying to reduce or to shorten or to make easier, break apart. But the most common synonym we use would be reduce. Rational, that's a fancy way of saying a fraction, because a fraction is called a rational number. So something like 2 over 3 is 0.66666, but it's a repeating number, so we're able to make it a fraction. Or something like 0.75 is 3 over 4. So a rational number or expression is something we're able to quantify or has a repeating decimal or some type of repeating part to it. But rational is the fancy word for fraction, and rational can imply a number, it could be an expression, it could be an equation, so many different ways we can use a rational term. And then expression means something that simply is a part of an equation, not an actual equation. Because if I had 3x plus 2, that's an expression, right? Because it's just literally 3x plus 2. But if I made it 3x plus 2 equals 5, that's different because now it's an equation. I can actually figure out what x is. Here with just 3x plus 2, I can't solve for anything, so it's an expression. I just have to, the only thing I could do is reduce it or break it apart or make it easier for myself. So that's the difference between an expression and an equation. So for these problems, the only thing we need to do, I don't see an equation, so the only thing we can do is simplify. Okay? For number 1, 45 and 27, let's worry about the coefficients, or the numbers in front first. I believe 9 goes into both of those. 9 goes into 45 5 times, and it goes in there 3 times. So I have 5x over 3x squared. All right, and then, now that I've worried about the numbers, let's deal with the variables. And now we're going to be getting into properties of exponents. If you have no idea what I'm talking about, how to reduce exponents with variables, check out some of my other videos. In the past couple months, I've posted a video or two about this, so you can get a good look there. But I will briefly kind of go over. When we're dividing with variables, or just numbers, if they're the same base, meaning the same variable or the same number, that means we can, and we're dividing, we subtract the exponents. But you might be saying, wait a second, there's no exponent on that top x. Well, there is. There's an invisible 1. So it's 1 minus 2, because I subtract the exponents, 1 minus 2, and that would actually give me negative 1. So x to the negative 1 power. So whenever you subtract the exponents, the answer goes to the numerator. And then the last thing is I can't have a negative exponent in my answer, so I have to move the affected term down to the bottom. And it's really important you don't flip the whole fraction, because the 5's good, the 3's good, it's just the variable and the exponent that are my issue. So I just need to move that particular piece to the bottom. So 5 stays on top, and then 3x to the first, or just 3x is fine. So that would be my answer. All right, here's another way to think about it. Going back to the green step there. You could rewrite it like this. So it's 5x on top, and then on bottom it's 3x times x, right? If I separated them. And then I can actually cancel out an x from the top and the bottom. So all I have left on top is 5. And on the bottom I still have a 3x. So another way to think about it. But that is essentially how you simplify a rational expression if they're both monomials on top and bottom. Obviously this can get a lot more complicated, but this is kind of the beginning work here. So let me do a couple more examples for us here. So number 2, worry about the numbers first. 18 over 54, 9 goes into both. Ooh, 9 seems to be fun. 9 goes into 18 twice, 9 goes into 54 6 times. And then, 2 over 6, I should have seen that. 2 goes in the 2 once, 2 goes in the 6 3 times. So I have negative 1 over 3, and I still have x to the third on top, and then x to the first, even though it's not written. We can write the invisible 1 exponent. 3 minus 1 is 2, so I'm going to write negative 1x squared over 3. And that would be our answer for number 2. All right, number 3. Taking a look here, 12 and 28. I think 4 is the biggest number that goes in there. 4 goes in the 12 3 times. 4 goes in the 28 7 times. So I have negative 3 over 7. And then r squared over r squared. So that means 2 minus 2 is 0, r to the 0th. And as we talked about, as if you look back, you'll see this in videos, anything, if it's a number or a variable, to the 0th power equals 1. So it's really just negative 3 times 1, which is negative 3 over 7. So that's that one. And then finally, let's go over number 4. 35, 28, 7 goes in the both. 7 goes in the 35 5 times. 7 goes in the 28 4 times. And then I have m squared and m to the first. I put that invisible 1 exponent there. 2 minus 1 is just 1. So it would be 5m over 4. So, again, this is the very easy, simplistic version introducing you to simplifying rational expressions. Things will get a little bit more complicated later on, but this is just the intro.